Hi everyone. In today's lab we're going to be doing two things. One thing that we're going to be doing is making a battery out of household materials for ourselves and checking the voltage that comes out of it that we make with just ordinary things, hopefully things that we can find around our house. And then the battery thing I will leave for you guys as an extra credit project. I was having a little difficulty getting a lot of current to come out of the homemade batteries to actually power anything. So as part of your extra credit, as an extra credit project I should say, you can go ahead and try and figure out how to get a good amount of current to come out of your homemade battery so that I could power something like, say, what we're going to do next, which would be an electromagnet, or simply powering a light bulb or something. I was using just a standard Christmas light bulb that I kind of took out of its little holder and hooked it up to some connecting wires and tried to work with that a little bit to try and get it to light up. If you're not interested in doing that as an extra credit project, you can more than be welcome to just skip ahead to the actual project that we'll be working on and be graded on, which will be the electromagnet that we will produce, and discuss sort of the qualities about the different types of electromagnets that we'll construct based on the types of wires that we use and how thick the wire is and what kind of cores and how big those cores might be for our electromagnet, and see how much power comes out based on that. And we'll kind of look at the relationship of the magnetic field that's produced by this type of electromagnet, which is technically a solenoid in this particular instance. So we'll look at that behavior itself. And then after that, I'll show a little demo sort of showing the application of electromagnets and the use of them in terms of transforming low voltage to high voltage and vice versa. So these are what we would term as transformers. So let's get started with the homemade battery. So we'll need to first gather some materials for us to construct that battery for today's extra credit project. So you'll need something that's usually non-conductive to contain the liquid that will act as our ion exchange between two types of metals that will therefore act as the cathode and the anode. Right. To act as our cathode or anode, you can use various things such as copper wire, copper pennies, and you can also use, say, zinc-coated paper clips, iron nails, aluminum foil. You can even use the tab on aluminum cans as well, like that. Go ahead and experiment with whatever you think. I'm more interested in what you guys come up with as a part of the extra credit project, so kind of surprise me as to what you can rig up in with what you might have just lying around at home. Certainly a couple of other things that you may need for your project as well. You might need some tape to kind of help hold things together if that's necessary, some cardboard just in case if you need to make sure things are set properly, and then some cutting devices, obviously some scissors. We can use that to kind of strip wires, and we can also use pliers as well, particularly needle nose pliers. At least my needle nose pliers has a wire cutter here at this point here where where it clamps shut like such. So obviously for very thin wires and delicate wires you can obviously use scissors to cut those, but for thicker gauged wires you'll probably need something a little bit stronger like pair of pliers or an actual wire cutter or wire stripper that would have wire cutters attached to them. So just a few things to get started with that. So what I would probably do for this particular setup, I would use, say, just a paper cup, and then you need to choose some sort of ionic solution that you might be able to come up with. Can be anything from like an acidic juice, vinegar, any salt solution. So even just mixing water with table salt might actually produce for us a good battery to work with. And you can even go into some sort of base or alkaline for that matter. I believe milk might be a base that can be used, but I can't remember my high school chemistry at this moment, so just bear with me on that. So yeah, anything that might be acidic, juices, soda, things like that, vinegar, so on and so forth. So, and then any sort of salt solution. I mean, you can use just regular salt if you want to, or if you want to try, say, Gatorade or something that's full of electrolytes and things like that, which would obviously help with the ion exchange between the cathode and anode. So, you need a cup. I would fill it with your liquid to about 3/4 of the way, and just need a little bit more here. And since we're working with wonderful liquids and stuff, I would recommend also having a few paper towels on hand just to kind of clean up your mess if you're dripping. I do, at least I don't encourage you to use more harmful chemicals. Certainly there are other household products that you could use besides, say, juices, sodas, and things like that, like bleach or things like that. I wouldn't really recommend you using that, as that can get a bit iffy, and I certainly won't recommend you going out and buying an actual acid like hydrochloric acid or anything like that. So please don't do that, or at least I will not condone such actions. So please be very careful when doing this. I'm trying for you to not really get damaged coming out of this, as you may probably want, because the more fun, more dangerous it is, obviously the more fun the experiment is going to be. So let's try and keep it at least somewhat fun and somewhat safe for today's lab. Alright, so I'm going to use, like I said, basically some grape juice inside just a paper cup, and then I'm going to use some copper wire. I'm going to just strip this and then just use, say, about 4 inches or so of copper wire, and then also use just standard paper clip for that. So what I've done already, and you can take some time to do this really quickly, basically just take the paper clip and fold it out like this in such a manner, and then you can just open it up like this, basically as a hook, and you can allow it to sit quite nicely into the cup like such for today's purposes. Once you get a piece of wire hooked up, or basically stripped, if it isn't stripped already, basically just take the piece of wire, and I would just recommend just bending it over, just like with the paper clip as well, and then just setting it off to the side like that on the other side. Right. The next thing that you would need is some sort of connective wiring. So I'll post a video on which to get some connective wiring from basically old cords that aren't necessarily useful anymore. So if you need connective wiring for that purpose, certainly you can go and take, like, say, an old phone charger or something like that. Make sure you ask whoever owns it if it's really not useful anymore before tearing it apart. And then once you have some connective wiring, then you can test out, hopefully, the voltage of that particular battery in a way that would not necessarily require us to get a voltmeter. So I was hoping for you guys to at least test out these types of batteries with the electromagnet that we were going to produce, or at the very minimum at least produce light from a light bulb, very small light bulb. But you can always purchase a small voltmeter at a hardware store if you're able to do that. Maybe Target or Walmart may have them as well if they're the only sort of locations open at this time to get that, or you can always get it online if you need to. So you don't really need much out of this. Basically you just need at least a DC voltage of 2 to 20 volts, since this shouldn't produce all that much voltage, nor should it hopefully produce very little voltage for us in the end. So once we get our battery connected with some connecting wires and I have the voltmeter hooked up, we'll see how much voltage we get out of this particular setup of a homemade battery. Alright, so I have it hooked up, the copper wire hooked up to the positive lead, and the zinc coated paper clip hooked up to the negative lead, and we're getting here approximately 0.91 volts of potential from our battery. If you go and look at conventional batteries, such as your typical AA battery that I had sitting around here, it was approximately 1.5 volts, and you can hopefully read that off the battery itself, at least on this Rayovac one. It's located underneath the indication that it's a AA battery. So we're producing only about 0.6 volts less than a conventional battery. However, the only issue that comes out of this particular battery that we constructed here is that we're not providing enough current to actually power anything of any note. So at least the way that I've constructed it thus far, we do get a voltage out, but not a lot of amperage. Due to whatever reasons that are going on here, at least from what I've read, we need to make the plates much larger in the battery itself in order for a larger current to actually flow from the cathode to the anode, and actually it goes the other way in that sense for conventional current. So yeah, so that's sort of your task for the extra credit, is to see whether or not you can produce a battery such that it makes quite a bit of not only a lot of voltage, and you'll find that as you sort of put more and more cells in series with each other, so essentially you can always make a series of batteries by essentially taking, say, more copper wire and attaching it directly, say, to these paper clips that we're using here, and then simply instead of having it connected like just with one cell. We might have a 2-cell battery in which we have something that looks like this, where it's connected in that sense. And so when we place that in there, we get a much larger voltage in series, and it is additive in that sense. So the more we add the more cells we add in series, the more voltage we get in total. So this is approximately, it's a little under twice as much. We would expect to see about 1.8 rather than about 1.7 volts if this was truly additive, but I'm sure this one might be registering a little bit less voltage, or there may be some internal resistances going on here that isn't necessarily being accounted for, and all that other fun stuff. So go ahead and play around. If you want to, you can make the cells, you make large series of cells. Certainly an easy way to do that, to make a large series of cells, is to use ice cube tray. Is one instance. You don't have to use as much fluid, ionic solutions or anything like that to sort of have that exchange of ions between your cathode and anodes. But certainly this just kind of demonstrates for us, at least with grape juice, copper wire, and zinc-coated paper clips, that we essentially get at least quite a bit of voltage out, at least comparable to the voltage that comes out of a standard battery, anything from AA all the way, or I should say AAA all the way up to, D-cell batteries and things like that. So however, again, the current on this, probably not that much. I mean, if I go and look at the current at that level, we're getting a little current, but it's a little erratic in that sense, and it looks like it's falling in that sense for DC amperage. And so I would expect this to just sort of taper down to approximately, I don't know, 0 or something, basically with a little noise. This is already 2 milliamp setting, so effectively this is already in the microamps. So not a lot of current being produced by this battery already. So maybe if there's a way to increase that. Certainly this isn't the only way to create an at-home battery. You can certainly use, you can always try using coins in a layered fashion in a pile voltaic cell. That might actually be of interest. You may use alternating pennies and nickels layered on top of each other between essentially some sort of soaked paper or cardboard or something like that that has a ionic solution that it's been soaked in, either something like grape juice or salt solution or something like that, that can then transfer those electrons through. You may be able to make a nice pile for that particular battery and get a nice current out. So play around with it, have fun, just be careful. If you have any questions concerning any of the things that you may need, don't hesitate to ask me. I can certainly, and I don't mind sending you anything that you might need, with the exception of probably a voltmeter. Basically, I can probably send you some wires or things like that if you're in dire need of things like that, and they can be pre-stripped and all that sort of stuff for you if you need it and request it as such. And I'll just send it in a just standard letter via USPS, so hopefully you'll get it in a few days if you need that. So again, have fun with it, and then I'll talk to you guys later.